Sure. I'm happy to introduce Tom. So Tom represents, as I think I mentioned last week, first sort of non-trusted CI speaker, though he certainly is a close friend of the project. He's been on our advisory committee, but some of you may know him from his role at University of Chicago, where he was CISO, and now he's got a more complicated title, which I'll let him help me with here in a minute. But I asked him to give a talk he gave recently at Globus World on engaging with research from a cybersecurity perspective. So with that, I really appreciate Tom's flexibility on joining us here on relatively short notice, and we'll turn it over to him to take away. Thank you, Tom.
Sure, thanks, Vaughn, and hello, everybody. I'm really interested and curious about you guys. There's been Vaughn and many others, of course, have been talking for quite a long time about how we can get the goodness of cybersecurity and the appropriate form of that out into the different science disciplines. And that's just a really hard problem. It's a really large problem. And one of the ways I think about the fellowship program is it's a step. You guys are all in your different places and disciplines and relationships with that overall large goal. And I think you're going to be a little bit like Dana's bees, if you were on the call when we were talking about that, going out and pollinating things, making things blossom and flourish from that perspective. So I've got the slides from the talk, as Vaughn mentioned. I kind of feel a little bit meta about giving a presentation. I'd kind of, given the circumstances who you guys are, maybe look at it as an excuse to discuss some things as we go along. So if you will please, if you box me into acting like a presenter, I might respond, but you don't have to. I'd rather just discuss things. So let me share the slides and I'll start talking about them, but please just interrupt me when it suits you to. Let's see, I think I have, there we go. Is that on your screen? Can you guys see a slide title?
Yep,
okay.
Good.
Okay, and there's my complicated title. Somehow Vaughn has a hard time keeping data privacy in mind, apparently. Okay. And I am split. I was the CISO at UChicago, and I am split evenly. I backed away from that so that I could spend more time with Internet2 and InCommon and stuff like that out in the world, which I am doing very happily. So here are some of the things that I really want to talk about with you guys. Security is about the mission. Some of my former CISO colleagues don't quite feel that way. I think they would answer this, they would say that security is a little bit more towards compliance. I've been always, or oftentimes a little disappointed when I get a new colleague just joining a university from someplace as CISO, and before they've started, they think they know what their work is, what their role is at the institution. I just think that's a real fundamental error. It's all about enabling the mission. And we can do that by helping to manage and reduce risk to the mission. There's security programs that are designed to enable research, and I'll show you one or two. There are scopes and scales to all this stuff. It's not all the same. And scale has an awful lot to do with the approaches that may be available, I think, to us that can have some effect in bringing whatever the value, the enabling value of security into the pursuit of the research. And so I'll get into trust frameworks, which is how I think about one of the things you can do when there's really large scale. Okay, so let's get into it. I'm going to have two cases, a simpler case and a more complex case that we'll look at a little bit, and then a little bit of a interlude between the two. The simplest one is human subjects research. And we'll have to defend that proposition in a minute, perhaps. Not that it's easy. So for me, this really, there's a great example I've worked a lot with here at the University of Chicago called Urban Labs. And they do really cool stuff. And you can kind of see my brief synopsis of their mission there on the right. So they're scientists, they're social scientists, but they're really trying to forward the public good by helping agencies that serve the public do a better job, basically. So it's a really nice cycle. They work in Chicago, they work in other cities, other states, countries. They do a lot of work in India, helping the Indian government and so forth. So it's a huge deal here. And the kind of data that they have to handle, I mean, some of it's subject to regulation, like patient medical records and things like that, but others are just toxic kinds of things, criminal histories and school records and various things. There can be some regulation, but in all cases, or almost all cases, there's some kind of deep concern, at least for the subjects expressed in that data, and by the agencies who then transfer their liability onto the university in order to enable those research programs to go forward. So those, there's the liability scene. There's data use agreements in the case of urban labs for the most part. Also business associate agreements, which is the HIPAA contract. If you're a HIPAA covered entity and you want to share some of your patient data with a third party, you're obligated under the regulation to have a business associate agreement which puts a lot of security obligations and liability on that partner. And so our urban labs in particular also is the University of Chicago on behalf of the urban labs has signed business associate agreements with healthcare providers to help them also do their part to improve the public good. There's also other government contracts, not from agencies, but through the federal government. There often are DFARS or FARS slowdown requirements increasingly these days, which basically boil down to having some rather onerous security and privacy obligations on the contractor. And so that's becoming increasingly common at universities. And there's also just the initial PII, personal identifying information, of state regulations, national regulations, the European GDPR, and all that kind of stuff. So the range of things that come to bear. And we don't want to mess it up, because in the worst case, that might mean this really cool program, area of research at which the University of Chicago, not uniquely, but quite impressively, I think, can do good in the world, could be shut down. It's not something I expect. It's an unlikely thing, but it's one of those things that's a possibility if we don't take sufficient care in managing that data and managing the liability. So, not surprisingly, urban labs and some other research efforts got their start before people in administration like me, a CISO, became aware of what was going on and realized, and they were very nervous when I first reached out to them with what they were doing. They were really grateful to have some qualified help join their activity and try to keep them out of trouble. They were very keenly aware of the existential threat to what they were doing, and were relieved that the institution was willing to help support them in a variety of ways. And so we did in a big way. I would say we currently now have an institutional strategy, that really is out of the office of the VP for research with these partners. And so the basic idea is that we have a range of policies and procedures and changes to workflows and new campus-wide services so that principal investigators don't have to figure this stuff out. We should basically, me or someone like me should just basically magically appear at the right times and help them to deal with the obligations they have at that time. And it's all in terms from the security perspective, it's based upon the NIST standards, right? There's really no escaping that. For some contracts, and generally, even though data use agreements often do not specify anything federal, it seems to be the right common denominator. That is, we have this approach, this kind of security program. It's good enough to address pretty much all of the different kinds of security obligations that come our way through data use agreements. Okay, so there's a good response to that stuff. The institution helping researchers manage this liability and deal with those obligations. So here's a picture we don't have to dwell on. By the way, let me stop for a second. Is this interesting to you guys at all, you fellows? Or is there anything you want to ask about it? Like maybe you should go out with each of your institutions and start one of these strategies or something like that? All right, well, I'll ramble on a little bit longer.
So this is Jay. Tom, thank you for the talk. I just want to echo, yes, I'm interested because I want to get a sense that how the research, how the security aspect for researchers is different from other kind of requirements. So I think that I'm interested. Thank you.
That's a really great question. I'm going to give a partial answer now. Maybe we'll it's more like a theme than a question, and maybe we'll come back and chip away at it a little later on as well. But the beginning of my response to your question, Jay, is that I kind of go back to how I think of security as being one of those disciplines that help enable the mission of the organization. And in the case of the University of Chicago and many of the places that you're at and what we're all concerned about here, research and science, scholarship, those things are, you know, the University of Chicago is a research organization, first of all. That's the mission. And so if I'm not justifying and rationalizing and, you know, what I do in that light, I'm not serving them very well. That's my opinion. So that also goes not just to research, it goes to other areas of the mission of the institution. So I can say, Jay, and my first partial answer is that that perspective, I think, can lead to interesting and appropriate kinds of engagements between security and other mission activities when you put the mission first. I sometimes remind people around me of this when I say that, you know, we're talking about, that we enable the mission by managing risk to it. That risk to mission is always the #1 risk on the list of risks, risk-based approach to things. So that somehow helps point in the right direction. Does that help?
Yes, so I look forward to continue to see the slide. For example, you said about Jupyter and some of these collaborative platforms that either the administrators put it in for researchers' needs locally or using some kind of cloud platform. So a lot of this practical use of them and how to advise the researchers. And this also another things because a lot of researchers have students. You have short amount of time to work with them to ramp up their access. So some of those things are practical questions. And what it translates to me as a researcher as well, cybersecurity researcher, is that, let me turn this on as well, is what does that mean? What does that mean for user behavior? What does it mean by the security measures in terms of reducing the type of risk? I think the risk environment is a little bit different. I think Vaughn gave a talk last week. It definitely shows there's some differences between the research environment versus the enterprise IT. Needs and the dynamics is a little bit different, which translate to the type of solutions and products that we may want to provide to researchers is different from the enterprise network. Thank you.
Yeah, I think that's right and reasonable. And there's a little bit of that reflected in this diagram and maybe in the slide behind. What's not all that evident in this slide is that this is sort of a picture of sort of how user access to and within the secure computing environment is managed. There's two key ingredients in this that are not all that evident. One is sort of there is delegation. Okay, so it's not just a centrally operated. There has to be delegated administration of an environment like this because there's people in the center don't know enough. Okay. So that's a huge part of it. And the other is the operational coordination. This operation depicted here is a joint venture between the university's Research Computing Center, which reports up to through the Vice Provost of Research, and Central IT, okay? And it has high performance computing elements, science DMZ elements, as well as more traditional, Linux and Windows kinds of environments and software in it. So all those red things kind of represent the array of different kinds of resources that we're ready to bring to bear in response to a particular project's needs. But the project PI is in control of who can access the project's resources directly, not just in policy, but they can actually press the buttons, and there's some help, some support in case they don't want to press the buttons, and also to remind them every now and again they should review, should the buttons be pressed again, that kind of stuff. So it's there's a lot that goes into the processes surrounding such a thing that have to appropriately embed in context, in the research context in this case. And so I think there's a lot of attention paid to that in Chicago and other places. So yeah, that's a partial, we'll go on, but I think that you should keep up with this theme, Jay. Ask more, or I can stop and ask if you want another question right now. Okay, I'll go on. Yes, Lawrence?
Yes, I'm wondering on this slide, if you want to ask if everybody knows what Grouper is, and it looks like you might use CI logon. I'm wondering if you share some of the tools with them that they may or may not be aware of, because that's one of the things they could then use, you know, to reach out to their new channel and to the broader community through the fellow program.
That's true. And I kind of didn't with Globus take this talk into tools land heavily. I can give you some references to leave you guys with a little later on in the folder in the Google Drive, perhaps. And of course, Trusted CI has folks that are really familiar with the kinds of tools that are appropriate. And so I think as the fellows may encounter a situation where it seems like maybe some kind of a bright tool would be a good idea, following protocol, raising that question back with Trusted CI, I think is very likely to get a good answer. So, all right. But Grouper is a wonderful thing, I have to say. It was a project that I led for many years, and it really is all about delegated management of a variety of things, and it's something at the University of Chicago and a number of other places around the world that's deeply ingrained. Every access to everything basically is managed through Grouper, or just about everything, far and wide around the campus, not just central administration things. Okay. So I talked about there being ongoing close coordination to make this stuff happen. Here are some of the teams that were involved, enlisted here. One of the cool things that I didn't really appreciate going into all this is how much additional benefit it would bring to the institution that central IT would learn how to do this, both from the technical operations perspective as well as procedurally, right? So it turns out that they learn in building the secure computing environment, actually something called the Secure Data Enclave, they learned how to build those building blocks. They have lots of procedures that are routinized now, like the network operations folks. They know how to label address blocks as being for supporting secure stuff and things like that. There's a lot of details. And so they've already started to apply those same building blocks to urban labs as new environment, for example. And so there's some other research groups around the campus that are thinking, do they want to run their own that has to meet the kind of high bar security requirements that they'd be obligated to, or they just want to go in with Secure Data Enclave, or do they want to have central IT build them their environment, but it's really not much extra skin off the nose of the institution if that's their choice, because they're just doing more of the same. So that's a real benefit there. The institution's in much better position technically to produce this kind of support. So this was the simple case. We had to build an environment. We had to teach a lot of people how to work together and what to work together towards. We had to have a lot of policy and procedure, and it had to all implement those federal security standards. That was unavoidable. But that close collaboration, I have to say, was the most interesting part of it and the most impactful. And that's going to be a theme. That's really the theme of this talk. We could do it here because we're all at one place. I can get the teams together with pizza. Pizza was one of the most effective security measures, I would say, in building UChicago's secure computing environment. Not a federal control statement. Okay. So now I'm going to go in a direction that Vaughn likes to go, and I've been thinking about as well. And so this is all, we can all blame Vaughn for this thing, and he got me thinking about it. And so for what it's worth, now maybe he told you all about this, and you guys can just wave me off, and we can save some time. But Vaughn's really worried, so am I, that the federal NIST security standards will assimilate all things in the world and make our lives hell. So we don't want that to happen. We want it to happen where it should happen. We don't want it to happen where it should not. So I stole this slide from Vaughn.
I have a question before you switch topics. Sorry.
Not at all, Matthias.
I realized I was muted. So so when you talk about the U of Chicago and talk about this, the security environment, that also include other projects like Jetstream or cloud environment provided by U of Chicago to public users, or is that completely different?
So the Secure Data Enclave part of the effort is that's operated. There's actually three components. There's a physical locked room thing. There's what we call a commodity Secure Data Enclave, which is operated by central IT, and there's a high performance component of the secure data enclave operated by the Research Computing Center, and the entire service is offered to the campus, to the researchers through the Research Computing Center. That is, the central IT part is just a back-end operation. I think that, and so we already have projects that have sensitive data that need to have a footprint in the secure data enclave, yet they want to use some of the, and the high performance portion is a clone basically of the capabilities of our high performance computing cluster on a smaller scale. But they want to have access to the larger scale, the tons of GPUs and all that kind of stuff in the unrestricted computing environment. So we work that stuff out. How can they keep the sensitive data in one place, cook it a bit, take the result that doesn't have the same sensitivity, move it into the open environment, and proceed and get the science done that way. Does that address your question, Matthias?
Yeah. So I was wondering about this particular project, Jetstream, which is what is a way. Yeah. So I don't know how close you were with those guys. I mean, given that they're also from UChicago, and I was wondering whether decentralized security plays works at all levels, or when it comes to this kind of project, they actually have their own little environment to avoid conflicts or possible overlap.
I think I get your question. It's more about how many independent efforts and do all folks kind of toe the same line and stuff like that. And more of an organizational question. Yeah.
And also providing how far you want to provide different computing environments to the researchers. Some you show in your picture, some of them they just want to use maybe Jupyter Lab, and that's all they need to access the data. Maybe others, some advanced users, they want to use containerized solutions, and they want to run their own infrastructure. I don't understand how the dividing line from your perspective into the into the projects.
So here's what I'll say. I can only answer this for the University of Chicago with any depth. I'd be really speculating for any other organization, even though I talk with many. So at UChicago, this whole strategy, the institutional response, is something that is governed, as many things at the university are, by the faculty, finally. Administrators are important, and they have big titles, but they don't always have the final say. Not really. Okay, so a key part of getting this to happen was to involve the faculty early and often, basically through their statutory governance bodies, which we did. And I've always been really impressed with our faculty and the seriousness of the role, their governance role. They get this stuff. They were waiting for us to show up, and all they really want is that we do something that's reasonable. They want to collaborate and stand on all the shoulders they possibly can, because they're totally focused on expending all their energy that they can on pursuing their research objectives. Any help, if anyone could take a piece off of their plate and make it more efficient, they're all for it. That's how they look at this.
So that's pretty good.
Yeah. So there still are. I mean, that sounds really wonderful, and it is. It doesn't mean that everything is perfect and apple pie at the University of Chicago. It's still a big, messy organization, and the word gets out, unevenly and that kind of stuff. But I think that the fact that we're doing the right thing and we're articulating that reasonably well bodes very well for the right outcome. And the right outcome is not necessarily one secure environment. That's often not the right answer, the best answer. So, but we're prepared to go to over time have the institution converge on what appears to be the right answer.
Right.
Okay. Okay.
Thank you.
Sure. So let's go on to the next one. So Vaughn, I was really surprised, Vaughn, when you at some talk in the last few months, year, I'm not quite sure, put this slide up here, and it was like, oh, for Christ's sakes, right. We've been looking at the wrong definition of security. And number one really is closer to where we're enabling the mission. Okay? 4 is one of the things that we all get fixated on, and it's so easy. It's like, oh my God, there's a mass shooting, all eyes on, or there's another weird tweet. Let's look at the spectacle. And it's not just a spectacle. It draws attention because of its spectacular nature when we have cyber attackers. It just makes headlines, and it's a real threat. It's something that we can't ignore. We have to do a lot, but it's not the whole situation, I think. And Vaughn Although I've known that, Vaughn first put words and slides to it for me, which struck me. So I have another way of kind of thinking about it, Vaughn, that I was thinking of you when I did the next couple of slides to see if it would help. And for the fellows too, because I think this question about what should happen with the federal security standards and what's appropriate security for different research contexts, this is something that you're going to help us all figure out, I hope. So here we have a picture. You can see the big blob in the middle is a cyber infrastructure system, and everything's cool. That's the way it's supposed to be. And on the right are a bunch of things that you don't want to have happen. Right? On the left, you've got what those bad guys, a sampling of what those bad guys might try to do. And then a security plan, according to Merriam definition number 4, is all the stuff we do to kind of respond and prevent and detect and respond to what the bad guys might do, these protective measures, okay? We don't want them to disturb the CI system to take it out of its design state to do any of these bad things over here, right? So then that's all true. And if we didn't have protective measures, by God, some of those guys would do some of these bad things over here and it'd be bad, okay? Let me just not belabor that too much. It's quite real. But it's not the whole situation. So if you just don't forget about, but just kind of, if my PowerPoint skills are better, I'd have that just sort of grayed out and missed it over somehow, but just crossed it out. Look at other things that can happen, either through a bad actor or through ordinary IT operations. I mean, can happen. It doesn't take a bad actor to misconfigure something, or for some flaw in a third-party component to interact unexpectedly with the rest of the system. Or when you do a restore from a backup, that it didn't work out quite the way you were expecting, you know? Things like that. Or that when you have systems that have multiple teams involved, as almost all do to some extent these days, that maybe the teams aren't coordinating all that well, and that can produce unknown states of operation, and all of which can potentially have those kinds of negative impacts, okay? So my point is, with this representative list of deltas, is that this is why we have in IT professional habits, you have things like SEV1s and problem management and incident management processes and change management processes, things like that are just good professional practice to try to reduce the incidence of things like this and hence reduce the incidence of the negative impacts that they often cause, okay? Apart from any security obligations that you may have. There's a big overlap between them. So I kind of took a look, I took this, I set up this set of risks. I have not done any research to decide that says these are the top risks. It's just out of the top of my head as representative ones, and looked at the NIST security control families and thought, well, do they, is something in there, does it address this risk? Not that it doesn't really, not making the judgment about how well, just is it in there somehow? And yeah, in several cases, there is stuff in the NIST plans that address misconfiguration with their configuration management stuff and flaws and all that kind of stuff. So, but there are two that are unaddressed as far as I can tell. That's that operational coordination is absent, and also the uncaught data transport error. I think they just haven't really focused on, everyone's assuming that the technology makes that impossible, and unfortunately, as Vaughn has pointed out and others have, that's not quite true. And we kind of get in that harm's way. In both cases, as I'm going to get to in a minute, as the scale gets bigger, we're more likely to be subject to downsides of these two factors. Okay. So let me go on and net out a little take on, well, what about, will the federal security standards, assimilate us all? And arguments on the yes side is, well, they're actually the right thing to do, or unavoidable at least in some cases, like with that human subjects research stuff. And some things, as the table shows, are well suited to even open science. You don't want any of those negative impacts. Those are bad for open science too. Have nothing to do with confidentiality of data. It's more to do with the integrity of your system, the availability of the system to keep, chunking along doing your science or making observations or what have you. reasons why they won't, or that'll work against the idea of them assimilating everything, is that they really need to have common executive management to go. Okay, it's very close to what you need to have to accept liability. Not the same, but it's close. And that tends to mean you need to have common executive management across a thing, a cyber infrastructure, a science project, a virtual organization. And as those get larger and span many organizations, that becomes harder to do. Also notice that there's a couple of those risks that there is nothing I can find in there that addresses it. And then I mentioned, this is not so much for your benefit. You guys probably know, and you're going to become the experts in the stuff and the ongoing developers, I imagine, of the Open Science Cyber Risk Profile and the Guide of Trusted CI. Okay. Keep that lack of operational coordination thing in mind for a little bit, if you will. I'm going to come back to it at the end. Now the complex case. Here's a poster child. There's many to choose from. This is Corbel, and it's in Europe. And the thing here is that there's these 13 different disciplines, not just projects in which, that have, there's a massive cyber infrastructure projects, each in their own right. They've all decided to go in together to varying extents, to have common cyber infrastructure services across this range of science. Okay, you can see as you look around some of those icons and things that there are some that are, well, there's no HIPAA in Europe, but there's certainly liability and concern and risk with regard to patient data and human subjects data in other ways. And so there's even some of that in here, but also there's stuff that's just plain science, no humans in the picture, no need about, having that kind of concern around confidentiality of data in some of these others, and they are all going together. So this is a big, I don't know you well enough to say big ask, but that's a big one, right? All right. Getting to know you that well pretty quick. So here's the thing. Science gets bigger all the time. Bigger teams, bigger data. You got to have more places to store and process and move it all around. And one university can't do it. And that's just not the natural way to do it anyway. It's international oftentimes. I mean, this stuff just doesn't know any organizational boundaries, and it's increasingly the case, right? But the funding never seems to go up anymore. We're happy if it stays level, right? And so what's that do? You need bigger stuff. You don't have bigger funding. You adapt. You spend the money over time. There's a variety of, that results in a variety of incentives that tends to, I think, concentrate things. Federation of various sorts becomes more valuable. Centralizing services becomes more valuable because it becomes more feasible to finance it that way. So that's the size. So the incentives, I think, motivate increasing size. When you increase size, complexity follows inevitably. And there's some stuff, Jay, there's even sort of some math and computer science that you could appeal to if you wanted to behind that statement, although I don't think we're quite at the scale where those theorems come to bear. But it's a principle that's real, right? So the complexity here, I'm calling out just a few things that I haven't done a good study of. In user access, when you have lots of users and they're spread over tons of organizations all over the place, it becomes more of a problem to manage their participation in the science. When the resources are all over the place, or if they have been operating autonomously at various locations like different campus high-performance computing centers, and you want to start putting them together so that they can be funded together, so that their union of their resources can be made available to researchers, and not just the maximum of each of those former independent components. So you want to be able to have a higher ceiling for what you can accomplish. Bigger projects, you got to federate things in some sense. Access management becomes difficult. All the other stuff at the network and data management also gets more complex. More kinds of stuff needs to be done to make that work out, so the time to results doesn't go up. In fact, hopefully goes down. Okay, so that's big is complex, and that's interesting. all right? What do we do about it? And from the point of view of security enabling science. So I'm going to focus a little bit on that federated user access stuff a bit as an example, because I know a lot about it, and I don't know how much of what's being done here will translate elsewhere, but maybe some. And so, and I don't know what you guys may know about InCommon and Federation, the research and education global federation space and stuff like that. I'll just kind of give a quick one-slide intro. Basically, you know, there's people doing research and scholarship all over the world at research organizations, universities, colleges, what have you. Their data, their papers, their instruments, their computing resources, they're also all over the place. There is, growing up in response to that, something called R&E Federation, which binds all of those things together in terms of managing access. And then much of that also is bound together at the network layer through research networks that are not, that are just you know, that are separate from the internet, so to speak, so that they can carry very big loads of data. So there's some numbers. There's 68 countries so far. There's entities, there's things in the way federation works that you have an identity provider, which is, you know, something operated by like the University of Chicago, where a user has a credential and they log in from their institution's login site, that's the identity provider, and they log in to something, some resource, some service that they want to use called a service provider. That's sort of the technical terminology for different kinds of entities that participate technically in federation. There's something called EduGain, which takes all the different national federations. They've almost all grown up as national efforts for a variety of reasons, and kind of binds them together in a way, okay? Pools their entities, many of them. And then there's also, so you can be inside of those clouds and benefit from federation. The federated access happens at service providers in the federation, okay? But it's also the case, and very often the case, that there are cyber infrastructures, scientific cyber infrastructures that predate all this stuff, or that are just, where the resources are just very different in nature. They aren't built and shouldn't be distracted by having to deal with weathering federation natively. And so there are proxies and gateways and things that bridge those in so that the benefits of federated user access can be brought to bear at research cyber infrastructures, like in that orange blob at the left of your screen. Okay, so that roughly is a sort of a snapshot of federation and the ecosystem that's built up and its scale. Okay.
Question, Tom. So they're showing me, just searching for this thing. Is it just access to the network, or is it actually data sharing and collaborative working research?
This is about, so good question. This is about users logging into things.
Oh.
So after you've got the network and can move data, there's the question of, should you? What's the access policy? We know it's not the case that just because it's on the network, the entire world should be able to access it, right? And the only management effectively in the network for that is IP-based access control. When you need more than that, when you need to have user access managed, different roles in a project, for example, you need to have some way of logging users in, knowing enough about who they are, managing what access they have to your service or facility or what have you based upon their roles and things like that. So this is a global infrastructure on which you can base those types of user access methods.
So is a separate, so think about University of Chicago. Your university has different access just for your university, but this is separate from that.
That's right. That's right. University of Chicago is only providing my credential and a few attributes about me to service providers around the world. They have no idea what I'm doing with that. Right.
And this is managed by your RC or by your IT people?
The IT people operate the identity provider.
Okay.
And it's just part of, And in fact, at Chicago and many places, but not all, but also there are many who are not, much of what is done on campus is done through the same facility. In other words, the identity provider is just one kind of a log and enterprise authentication service. There's also Radius, there's also, you know, Active Directory, stuff like that. There's LDAP, but there's also this one that does it over SAML, you know, and that's, so it's a single, this is all, I don't say it here, but it's all web single sign-on kind of technology.
So if you think about that, if let's say for enterprise network, University of Chicago's enterprise network, there might be some kind of monitoring, kind of looking at user access and some anomaly and stuff like that. So for this global federated case, is there any entity monitoring that, what kind of traffic, what kind of access is going on out there? So for example, if I'm part of this network, if I got compromised, I could be an entry to a lot of global things that's not, I'm not part of University of Chicago, but I'm part of University of Chicago. So is there any entity that's really monitoring and looking out for this thing?
Good question. I'm going to address that in just a second.
Okay.
Short answer is not in the way you might expect, because there is no one organization that operates it all. No one is responsible for the whole thing. It's too big for that, right? But nonetheless, the concern that you just voiced is really important, and there's a response to it. You're giving me a softball for why trust frameworks are necessary tools and useful tools. Okay, so let me kind of go on. There's a picture here about stuff that seems to be valuable in research and education federations that they need to provide and how things should have to work out well in this pyramid. And each of the lines in those bottom two tiers is a way of talking about the value of a specific trust framework that I'm going to just briefly show you a snapshot of in the following couple of slides, okay? This first one, accurate and complete metadata. The benefit here is a good user experience, basically, okay? And what does that mean? Well, this is really technical and operational, but all of those 68 national R&E federations, the kind of the guts of what it is they do is embodied in this metadata that basically identifies everything you need to know about each identity provider and each service provider in a technical sense, so that they know how to authenticate each other and know how to transact with each other to make the federated user access stuff happen. So that metadata can be good and be, in a variety of ways, turn out to be helpful to the user experience, or it can be kind of sloppy and crappy and make for worse user experience, among other possible benefits. The security one you just talked about, Jay, I'll get to that. There's a few attributes I mentioned that are good things to have and aren't available often enough, and then there can be, as you get into using federated access to access resources that have more risk associated with them, where there's deeper or more specific concerns of the folks who have obligations, maybe have liability to be responsible for, where they might want to know a little more about the credentials and the users coming their way by means of federation. Let me look at each of these very briefly. This is about InCommon's efforts recently, over the last year or a little bit more, to clean up its metadata. You can see at the beginning, in February of last year, it was crap. And now, this isn't the newest slide, it's actually nearly 100%. We've pretty much, we just about all but finished this line of work, and the metadata is sparkling clean, which is wonderful. How did we do that? Something called baseline expectations. Basically, InCommon decided, and its community boards, which I won't really get into now, decided that if it didn't do things like that and have good implementation of worthy, valuable trust frameworks like that, we should pack it up. If science and scholarship wasn't going to be able to make good enough use of that, they would do other things that would be good enough for them. And so it was important to invest enough and change things so that those valuable properties are realized. So they put together a program that has community-led processes, has legal stuff in the contract that participants in InCommon have to sign, and so on, and a ton of work to move that graph from 13% to 99%. And that's just the first step. Okay. The point is that here is an organization that doesn't control anything, not really, but it's in the unique position to really drive and influence, and that it takes a lot of process and time, just a lot of people time, to produce an effect, but that it's possible to do so even at a very large scale. InCommon has hundreds and hundreds of participants, thousands and thousands of entities. All that stuff, near 100%. Okay, we didn't lose anybody. We kind of wondered if we asked people, if we kind of said you have to, would some say, forget about it? None did, not one. So that's great. There are some other things planned. Basically, this slide basically says that the group, the community group that is governing this process is looking at that pyramid and those lines in the bottom two tiers and thinking, that's where baseline needs to go. What are the steps we should take in which order? And they're not quite done deliberating, at least the next step. I think, Jay, it's a very safe bet. It's going to be based on focus on that security need that you identified. And so that is called certify. And I may make the next slide. Nope, let's go to certify. I'll skip the other one for now. This is what do you do when a credential's been compromised and it's used to access stuff through Federated, through the Federation. And so there was a trust framework that's been created to address that. It still has a long ways to go, but the basic idea is in the left there, that the organizations, IDP organizations that operate them and organizations that operate service providers should agree. If someone contacts me and says, hey, I'm a service provider, and it looks like something weird is happening with one of the credentials at the University of Chicago, University of Chicago commits to responding to that as best it can. It's part of it, right? There's no contract here that obliges us to. We have to be entrusted to, but a trust framework like this makes specific. Well, what does that mean? So I know what the ask is. I know if I pledge that we're going to do this, it's clear, it's concrete, and realistic for me to make that commitment. It also says I'm going to have some basic operational security protections for our identity provider and any service providers that the UChicago operates, okay, and that kind of stuff. And they're not going to tell me how much I have to invest, because risk management is always an organizational priority, and so it has to be in line with the organization's risk management. Okay, so that's an example of a trust framework. There's a working group, I believe the working group, the international one, that's working on this and is working on extending this to all the other players in Federation, whereas this talks about each of the organizations that are members of federations. And the rest of the work is sort of a handbook on incident response across all of the things in this picture. And so that we kind of complete the incident response picture so that people should know what to do and minimize time to respond in case of that compromised credential, Jay. There cannot be contracts. There cannot be concrete obligations in this environment. 6,800, there's nearly 10,000 organizations. It's just not amenable to that kind of an approach. You can't have a NIST standard here. Most of these places don't give a darn about the U.S. federal government, and even less so these days, I suppose, but they never did in terms of NIST anyway, that's for sure. They've got other things, a variety of different things they have to pay attention to or not. And that's just the field we're playing in. Can't change that, we have to work with it. And so what we do have instead, and we're going to kind of cut to the chase here, and here's by the way, I'm going to come back to that thought. Here's another one about assurance and multi-factor and so forth. I'm not going to go into it. All of these links are live and take you right to the place that tells you about it. So a little later on, if you like, you can click into them. And if you have questions about them after today, I'm happy to try to address them.
I think you're aware of the time, Tom?
I am, yeah. So I'm just about done on. So we have to deal with what we have is what I call trust frameworks. Is kind of the only real tool available to us to kind of get all of these organizations across these massive infrastructures to produce some of the risk mitigating effects that in a single organization you might accomplish by having common management, enforcing compliance with things like federal standards or others, okay? But since there's no contract, there's no stick, you kind of have to, what is it that you base it on? And for me, why I think this actually works is because we're in research and education. We all share a common mission. We all know that about each other, and we're used to trusting, in some sense, each other in pursuing that mission where we have overlapping interests in it. That's kind of unique in research and education. So I look at a trust framework as sort of a little machine that takes that basic trust based on our shared mission and produces some predictable behavior that's useful for managing risk. Okay. Okay. And that's the basic, and then it can happen as the baseline expectations program in InCommon and some other examples. It's possible that some organizations can put a little more into it by monitoring, reporting back, maybe operating processes, like the Common has to verify or even compel adoption in some regards. The baseline expectations in the InCommon Federation is an obligation. It's a contractual one. So when the community governance board that drives it and the community processes arrive at consensus on a next step that should be taken with baseline, it becomes a legal obligation in time for members of the Federation to adequately observe it, okay? So that's unique and in InCommon. No other federation, national federation in the world yet does anything quite like that. Some have things in effect that have a similar effect. Many do not. And that is currently a big topic of discussion at the venues where all the folks that operate these things get together and talk about stuff. Okay, so that's pretty much it. Now, I asked you to hold on to this lack of operational coordination IT risk factor and think about that in these very large-scale contexts where a pizza's not good enough. You know, you can't serve enough pizza and get everyone together at one time. But that these trust frameworks, I'm not saying they do as good a job. They're a different tool in a different environment, but they produce some of the same dividends, I believe. And so that's kind of it. I think I've come to the end. Oh, yes, there we go. So I'll hold on and see if you guys have anything further you'd like to add or any business to address.
I have one question. Well, actually, a suggestion. So, thank you for your talk. That was very, very insightful and very useful. I was wondering, can you share with us, a security risk case that you face, with your experience, working at UChicago? What's been like the worst case you have to, or you had to, solve or confront when you're working there, like as head of the security group?
You mean in terms of enabling science and research, or just the worst case, unbounded?
Attached to research. Yeah.
Yeah. Okay. Well, first of all, I wouldn't say, I don't use the word worse. I've had personally, it's been fun. It's a lot of work, but really good stuff. I've had a number of, I'll give you some summary of the engagement. So with the Research Computing Center and with all the folks with that secure research computing strategy that we talked about earlier, I've worked with Globus extensively. So Globus, I think you guys may know, big in data transfer and data management. And so they had a lot of requests to be able to, folks that operate secure computing environments at medical centers and places like that, or Department of Energy labs where they have, or other federal agencies where they have higher security obligations imposed on them from above. but where the point is where they had those kind of federal standards kinds of security obligations that they needed to operate under, and they also wanted to have Globus data transfer inside. So I worked with Globus to get them to that point, and that they're there, which meant that they had to change a lot about how they operate their back-end stuff in Amazon, so that the University of Chicago can sign business associate agreements on their behalf, and also change some features of the product, the thing that gets installed inside someone else's protected environment, so that that thing would be amenable to helping allow them to continue to manage their security, their federal style security obligations in their protected environment. So I've done that. I've worked with Urban Labs folks, as I've mentioned. I've worked with some other groups in the social sciences, some other IT, we're university and we have different divisions in schools, and each of those has their own IT as well as central IT. And I've worked with some of those IT shops with helping them understand how they, to help them feel better or to help them adapt how they support their faculty's research when it has these kinds of obligations, that kind of stuff. I wouldn't say what's worst, but I will say, Mati, those are all positive engagements. With varying degrees of risk associated with them. But I will tell you a worry, if you like. When I was CISO, one of the things on my short list of what would be some of the worst stuff that could happen to this place, right? And you think about, big, patient medical record dumps, which would be really bad, or donor information dumps and stuff like that. Yeah, those are really bad days, and those can cost millions of dollars and be just terrible things. But I don't think they would really terribly damage the mission of the institution ultimately. Something that really could would be a bad guy getting on some HPC cluster in our science DMZ and using it as a weapon to blast the hell out of other folks on the internet. That would be bad enough on its own. But what the worst case scenario is, I couple that and I think, oh gosh, if that gets in the news, and some politicians start to question, oh my gosh, you mean scientists have things like this? Should we let them continue to play with such toys without supervision? I just, that's a place I never want the world to go. And that kind of thing could have really chilling effects on kind of the big science that we're talking about here in part today. So that's something, Matthias, that I really worry, I still worry about it, but I'm not going to be the one to actually be on the hot seat, or not that much, I think, should it happen. But it's something that I worry about. Globus people, their data transfer nodes are installed oftentimes in locations like that on Science DMZ. So apart from this whole thing about putting one in a protected environment, I really impressed upon them. Make sure that what they download, when they put a DTN in their Science DMZ, is what you produced. That no one has slipped a Mickey into it, basically. They should have procedures to address that risk, and they do now. Likewise with Slate, another project here, open science kind of a project, Matthias, that's being developed. It's meant to go in Science DMZs, and I've had that message with them as well, and they're doing their best to think about how to maintain the integrity of these platforms when they go into terribly exposed environments like that, so that they don't become weapons for somebody else.
This has been so great. I really appreciate it. And I think I want to follow up with you on several topics, since I'm also working on the national research platform related to those Science DMZs. But I also want to let people drop off if they have another meeting coming along. So I want to thank everyone for showing up. And Tom, again, this was terrific. Thank you so much.
It was a lot of fun. Thanks, you guys.
Thank you.
I'll stop the sharing now. And let me know, if you have questions or if it develops later on. Obviously I can talk for indefinitely, so I'm happy to continue doing so upon request.
Awesome. We appreciate it.
Sure. See you guys.
Bye, everyone.
Thank you all. See you next week.
Bye.
Thank you. See you next week.
Thanks. Bye, all.